Hello, and welcome to the first college algebra exam review. Make sure that you've attempted or at least thought about how you would solve these problems before watching how we do the solutions. So let's go ahead and get started with number one. I have this linear equation, and I need to simplify my answer and show all of my work. Okay. So I'm looking at this, and I think the first thing that we need to take care of are these parentheses. So I'm going to go ahead and distribute the 3 into the parentheses, and I'm going to distribute the 5 into the parentheses. All right, so let's go ahead and do that. I'll have 2x minus 3 times 4x should be 12x. A minus 3 times a plus 5 should be a minus 15. And then I have another minus 3. Okay. What's that equal to? I'm going to have 5x times 2 is going to be 10x. 5x times a minus 3 is minus 15x. And then we have plus 7. Okay. So let's go ahead and combine our like terms to make our equation a little bit simpler. So on this side, if I combine my 2x and my minus 12x, I'd have a minus 10x. And minus 15 minus 3 should be minus 18. Okay, and then what do I have on the other side? I have a 10x minus a 15x. So that should give me a negative 5x. Perfect. And then I just have a plus 7. It's just hanging out. Okay. All right. So then my next step is to go ahead and get my x's together and get my constants together. I want my x to stay positive, so I'm going to go ahead and add 10x to both sides. Okay, that leaves me with a negative 18 equals minus 5x plus 10x. That should be a positive 5x. And then I have a plus 7 still. All right, second to last step, let's subtract 7 from both sides. Perfect. That should give me a negative 25 equals 5x. Our very last step is to divide both sides by 5. And that gives us that x equals negative 5. Perfect. Great work. Alrighty, now we're going to look at problem number 2, part A. We need to determine whether this equation is an identity, a conditional statement, or a contradiction. I should say identify. Okay, and then let's go ahead and do that. So let's, again, I see some parentheses, so let's go ahead and distribute our constant into those parentheses to both terms. Boop, boop. Let's do that first. So I'd have 6x, 2 times 3x, and then 2 times a minus 5, minus 10, plus 12. That's going to equal 3 times 2x, which is 6x, plus 9. And then we have a little minus 7. All right, let's go ahead and combine our like terms. I'm already noticing that we have a 6x on both sides, so that's going to disappear. Okay, so then I'd have, if I really wanted to, I could subtract 6x from both sides. Maybe let's do that. Okay. So then I'd have minus 10 plus 12 equals 9 minus 7. So then I have minus 10 plus 12, that'll give me a positive 2. And then 9 minus 7, that will also give me a positive 2. Okay, so then I'm left with a statement that is absolutely always true. 2 is always equal to 2, so I know that this must be an identity. Okay, perfect. Okay, now taking a look at part B. I still have some things in front of my parentheses, so I'll go ahead and distribute that. I'll have x minus 3 minus 2x minus 5 equals 2 times x gives me 2x, 2 times 3 gives me plus 6, and then I have a little minus 11 on the outside. Okay, so now I've got to combine my things, all my like terms. I'll have x minus 2x, that should leave me with a minus x, and minus 3 minus 5 should give me a minus 8. On the other side, I have 2x plus 6 minus 11, so then my 2x is going to stay, and then I'm just going to have a minus 5 on this side. All right, and then I just need to add my x over, so then I have minus 8 equals 3x minus 5. Okay, and then I can add 5 to both sides. Then I'll have that minus 3 equals 3x, and I conclude that x equals -1. Now this is a statement that is sometimes true, and in fact we know that it's true for this particular equation. We know it's true for B, but for example, it may not hold for C, so we know that this is a conditional statement, because it's true sometimes. All right. Okie dokie, let's look at part C. Oh, make sure I have a pen selected. Okay, I'll do part C. Again, I have some constants in front of my parentheses, so my first step should probably be to distribute that out. All right, then we'll have 3 plus 5 times 2x gives me 10x. 5 times 3 gives me 15. That's equal to 8x plus 3x times 2x, 6x. 3 times 4 is 12. And then I have a minus 4x on this side. Okay. Beautiful. Now let's go ahead and combine our like terms to get our equation looking a little bit simpler. On this left-hand side, I'll have 3 plus 15, so that should give me 18, plus 10x equals my 8x. Oh my goodness, I have a lot of x's over here. Okay, so I have a 6x minus a 4x, so that would be a plus 2x, and then 8x plus 2x is going to be 10x. Okay, awesome. And then I have plus 12. Alrighty. And then I have a 10x on either side, so I know it's going to disappear, but I'll go ahead and write minus 10x and subtract it from both sides. Okay, and then I'm left with this statement. There should be alarms ringing in your head. This is not true. And so we know that this must be a contradiction. All right, now let's go ahead and move on to rational equations. We're going to start with part A. I have 5, 3, and 10 in my denominator, so I could take the prime factors of all of those and multiply them together to find that my least common denominator, what it should be. So let's go ahead and do that. 5 is 5 and 1, 3 is 3 and 1, they're both prime, that's quite nice, and 10 is 5 and 2, and then 2 is 2 and 1, so we don't need to do anything further. So then our least common denominator should be 5 times 1 times 3 times 2. We just take everything that we see that's unique, equals 1 times 2 times 3 times 5. 5 times 3 is 15, 15 times 2 is 30. Okay, so we've got that out of the way. We found our least common denominator. So now what we can do is go ahead and multiply each term by our least common denominator. So what would that look like? I'll go ahead and write 30 times 4x 5 minus 2/3 equals 7x minus 10 over 10 minus 2, and I'm multiplying 30 by the entire equation. So that would turn into 30 times 4x over 5 minus 30 times 2/3 equals 30 times 7x over 10 minus 30 times 2. Or I could write minus 2 times 30. It's the same thing. Okay. Perfect. Now let's go ahead and get rid of our denominators. That's why we multiplied through by the least common denominator. Okay, so 30 divided by 5, that should give me 6. So now I have 6 times 4x. 30 divided by 3, that should give me a negative 30 divided by 3, excuse me, that should give me a minus 10, and then I'm still left with a 2 in the numerator. Okay, and then I'm going to look at 30 divided by 10, that should give me 3 times that 7x, and then minus 30 times 2, that should give me minus 60. All right, let's keep going. Now we just need to multiply out some of our values and combine like terms. So then we have 6 times 4x is 24x minus 20 equals 21x minus 60. Amazing. Okay, so then let's subtract 21 from both sides. Perfect. Then what are we left with? 3x equals, 3x minus 20 equals a minus 60. Then we can add 20 over. Perfect. Then we have 3x equals a minus 40. So we conclude that x equals negative 40 over 3. Perfect. Okay, let's move on to problem B. As I'm looking at my equation, I can kind of think to myself, what is the least common denominator here? I have 5x and I have x. So my least common denominator here should be just 5x. Okay. So now I can multiply through by my least common denominator, or I could choose to have everything match. I think I'm going to go ahead and multiply through by my least common denominator on every single term. So I'll go ahead and write 5x times x plus 3 over 5x plus 2. Oop, don't want to do that. Equals x minus 4 over x. So my whole equation is being multiplied by 5x. Perfect. So then I'll really have 5x times x plus 3 over 5x plus 5x times 2 equals 5x times x minus 4 over x. All right. So now let's do our division. 5x over 5x, what does that give me? That's just 1, so I just have x plus 3. 5x times 2, that should give me 10x. 5x divided by x should just be 5, and then that's still being multiplied by that x minus 4. Perfect. Okay, now let's distribute this 5 into our parentheses. And actually, before I do that, I'm going to combine this x and 10x so that I get 11x plus 3 equals, I'm going to distribute that 5, so I'll get 5x minus 20. All right. So now I just need to subtract 5x from both sides. So then I'll have 6x plus 3 equals a minus 20. Then I'll go ahead and subtract 3 from both sides so that I get 6x equals negative 23. Right, my last step is to divide both sides by 6. So then I get that x equals negative 23 over 6. Perfect. All right, let's look at problem 3C. And here, my least common denominator might not be as clear as it normally is. So let's go ahead and factor that the middle term's denominator, and see if that gives us a clue as to what this least common denominator might be. N squared plus 3n minus 4. I can, if I were to set that equal to 0, I could rewrite this as two numbers that are going to multiply to negative 4 but add to positive 3. Well, that's going to be n minus 1, n plus 4. Okay. And so this must be our least common denominator. All right. So then I want to make all of my terms have that same denominator so that I can effectively get rid of it. So then I'm going to look at my my first term, and I want this is my least common denominator, n minus 1 times n plus 4. So I notice in my first term, I only have an n minus 1 in the denominator. So I need to multiply by an n plus 4 in the denominator, but also by an n plus 4 in the numerator so that I don't change the value of my expression. Okay, so what would that look like? I would have n plus 4 times over n plus 4 times 1 over n plus 1, or n minus 1, excuse me. Okay. And so then I just kind of do that for each term. We already factored the denominator of this middle term here. We know that it's n minus 1 times n plus 4. That already is our least common denominator. So this term is missing absolutely nothing. Has everything that it needs. Perfect. Okay. Then we move on to our 3 over n plus 4. It needs an n minus 1 in the denominator, so we multiply by n minus 1 over n minus 1 as not to change the value of our function. Times n minus 1 over n minus 1. Okay. Alrighty. And then we know we can go ahead and distribute some of our terms here and rewrite. So I have n plus 4 times 1, so that's just going to be n plus 4 over n plus 4 times n minus 1 equals 5n. That's not going to change. I'm going to go ahead and write the 5n and the 3 under the same denominator because they have the same denominator now. 5n, and then I have a minus 3 times n, so minus 3n, and then a minus 3 times a minus 1, so plus 3 up top. Okay, perfect, all over n plus 4 times n minus 1. Okay, so now I have this, and I'm about to get rid of my denominators, but before I do that, I'm going to go ahead and make a note of what values n cannot be. So what values would make this function undefined? Okay, well, I know that undefined means that there's a 0 in the denominator, so I look at what values would make my denominator equal to 0. And I can see that if I plug in n equals -4, or if I plug in n equals 1, I get a 0 in the denominator. So I know that these must be my restrictions. Perfect. All right, now let's proceed. I want to get rid of my denominator, so I'll just look at one side and I'll say, okay, I'm dividing by n plus 4 times n minus 1, so let me just multiply both sides by that to get rid of it. Perfect. What do you notice? The denominators are gone. It's beautiful. All right, then what are we left with? N plus 4 equals 5n minus 3n. Well, that should just be 2n plus 3. All right, and now I'm going to subtract 1n over. And then I have 4 equals n plus 3. So then we conclude that n equals 1. Hold on. Wait a minute. We said that n cannot equal 1 because that's one of our restrictions. Oh no. Okay, so n has no solutions. We can write n as the empty set. We can also write the empty set like this, but it has no solutions. So this is just a bunch of ways that you can say there are no solutions for n. Okay, great job. Okay, let's move on to 4a. We need to solve 4x minus 3y equals 6 for y. Let's do it. 4x minus 3y equals 6. I think my first move is probably to isolate y, get it all by itself on that left-hand side. So my first move should be to subtract 4x from both sides. Perfect. Then what am I left with? Negative 3y equals 6 minus 4x. Don't combine them, they are not like terms. All right. And my last step is to divide each term by negative 3. So that we know that y equals, we can go ahead and divide each term out. So 6 divided by a negative 3 would be minus 2. And then negative 4 divided by negative 4x divided by negative 3 will be a plus 4/3 x. Awesome. And then we can also write this as 4/3 x minus 2. Okay. Perfect. Let's take a look at 4b now. We do not have a specified variable here. Okay, so we're just going to go ahead and skip this one. I don't believe it shows up in your solutions either. But we are not specified a variable, so just skip 4b. All right. Fantastic job so far. Let's go ahead and look at number 5. Sally just retired and has $50,000 to invest. She needs to make $6,000 a year from interest to meet certain expenses. She has decided to invest some of her money in a bond that pays 15% simple interest. The rest of her money she plans to put in a CD that earns 7% simple interest. How much should Sally invest in the bond fund and how much in the CD to earn $6,000 a year in interest she needs? Answer with a complete sentence and show all of your work. Okay. So, immediately I know that Sally is going to be making 2 investments into a bond and a certificate of deposit. The total amount invested in both I know has to sum to $50,000 because that's the total amount invested. I also know that the total interest accrued, I want that to be equivalent to $6,000. That's how much she needs to earn. Okay, so maybe let's set up a little chart. I'll do one for the bond. The bond comes first. So I'll go ahead and write bond, and then I'm going to write CD. Okay. Oh, it doesn't do the thing where it makes it straight for you. Okay, and then I have, we're going to look at principal, rate, and time for both the bond and the CD. Awesome. And I know that P times R times T equals interest. So I know when I add these, once I multiply the things in each column together and I sum them, that should equal my total interest. Okay. So let's go ahead and get started. So we don't know how much is invested. In fact, that's what we're trying to find out. So maybe let's say that that Sally invested X dollars into the bond. So then how much would Sally have to invest into the CD so that this, if I add X and the amount in the CD, I get 50,000? Well, I would need 50,000 minus X. Okay, so I add those together. Okay, so that's just maybe a different way to think about it. Okay. Now, I'm going to look at the rate of interest. So the bond pays 15% simple interest, so I'll go ahead and write that as a decimal, 0.15, or divide 15 by 100 if you'd like. And then we're going to put it into a CD that earns 7% simple interest, so that's 0.07 rate on that certificate of deposit. Okay. She needs to make $6,000 a year. Okay. So it looks like we are just doing this for 1 year. Yeah, we need to make $6,000 per year, so we're doing this for 1 year in both the bond and the CD. Okay. Okay. So then I know that I need to earn $6,000 a year in interest. So I know that the interest that I earned from the bond plus the interest that I earned from the CD together, that has to give me $6,000. That's what Sally needs here. Okay, so then how could I calculate the simple interest accrued in the bond over a year? Okay, well then we should go to our handy dandy little formula, for simple interest, I equals PRT, which is kind of what we set up with the table here. So now I know that the interest accrued in the bond is going to be X, our principal, times our rate, 0.15, and then times 1, but I'm not going to write that because everything's multiplied by 1. Okay, and then I'm going to add now the interest accrued in the CD. How would I compute that? Well, I'll do my principal, 50,000 minus X, times our rate, 0.07, and then times our time, but that's 1, so I'm not going to write it. Well, maybe I will. Okay. Maybe I will. All right, and then all of that is going to equal 6,000, because that's what, that's the amount of interest that I need to make. Okay, so now we just need to, we'll need to do a couple of things. I'll need to distribute this 0.7 kind of backwards into these parentheses, and then I'll just have to multiply the rest the rest out. So I have 0.15x, and then we have 50,000 times 0.07, so that should be 3,500. And then 0.07 times x is minus 0.07x. All of that's got to equal 6,000. Okay, so then we subtract our 0.15 and our 0.07. We get 0.08x plus 3,500. And I realize I made a typo here. 0.08x plus 3,500 equals 6,000. And then we subtract 3,500 from 6,000, and we'll get that 0.08x equals 2,500. Okay, then we divide both sides by 0.08. Okay, and that gives us that x equals $31,250. Okay, so immediately we know that the amount invested in the bond. So let's do a little bit more work to find the amount invested in the CD. Okay, so maybe we can write bond here, and then we will have to do a little bit of, we'll have to do some computations to find how much was in the CD. 50,000 minus x, or 50,000 minus minus 31,250. That should give us 18,750 for the amount that we need to invest in the CD. Okay, so we can write that as a complete sentence. Sally should invest $31,250 in the bond and $18,750 in the CD to earn $6,000 in interest. Over the year. Awesome. And that's maybe a little bit more wordy than you need to do it. You could probably just stop Sally should invest $31,000 in the bond and $18,000 in the CD. Yeah. Okay, great job. Okay, let's go ahead and get started with, okay, let's take a look at number 6. So Helen is planning on mixing fruit juice and soda to make a punch for a party she is hosting. She can purchase fruit juice for $8 a gallon and soda for $6 a gallon. If Helen wants to make 28 gallons of punch at a cost of $6.50 a gallon, how many gallons of fruit juice and how many gallons of soda should she purchase? Answer with a complete sentence and we'll show all of our work. Okay, so I know that the amount of fruit juice plus the amount of soda being put into this punch should equal 28 gallons. So maybe let's let X equal gallons of fruit juice. Okay, well then I know that the amount of fruit juice plus the amount of soda has to equal 28, so then I can conclude that I must have 28 minus X gallons of the soda. Okay, amazing. And then when I add those together, I do in fact get the 28 gallons that I'm looking for. Okay, so then we're going to kind of set up a cost equation. I know that Helen wants to make 28 gallons of punch at a cost of $6.50 per gallon. So I know that my cost at the end of the day is going to be 6.5 times the number of gallons that I have, 28. Okay, perfect. And now I want to know how much money I'm spending on the fruit juice and on the soda in particular. So if I have X gallons of fruit juice and I'm paying $8 per gallon, I should just write X times $8 to find out how much money I'm spending on that fruit juice. Similarly, for soda, I know that I have 28 minus X gallons, and I'm going to be purchasing that for $6 per gallon. Okay, so now we have this equation, and we can start to solve. So I have x times 8 is the same as writing 8x, and then I'm going to kind of do this backwards. I'm going to distribute my 6 into my parentheses backwards, and I'll have 8x, 6 times 28 gives me 168, and then negative x times 6 is minus 6x, and then that equals 6.5 times 28 is going to give us 182. All right, so then we just start to combine our like terms. 8x minus 6x is 2x, plus 168 equals 182. Then we can subtract 168 from both sides, and we get that 2x equals 14. So then x must equal 7. All right, so then we know that there were 7 gallons of fruit juice purchased. So now if we wanted to find how much soda, we would just plug it into our 28 minus x equation. 28 minus 7, well, that better be 14. And that's going to equal the gallons of soda. Okay. So then we're able to conclude that Helen should purchase 7 gallons of fruit juice, and 14 gallons perfect. Great job.
All right. So problem 7. 2 planes fly in opposite directions. One plane is traveling 450 miles per hour, and the other plane is traveling 550 miles per hour. How long will it take the planes to be 4,000 miles apart? Okay. So if I think about this, I have some rates and I have some distances, and the question is how long? So we might be thinking about what is the relationship between distance, rate, and time. So I know that my rate is equal to a distance over time, or you might know that distance equals rate times time. We can also rearrange this to be that time is equal to distance over rate. So all of those are equivalent things that we can say. And so let's think about what we need to say here. So the planes are traveling in opposite directions. So we have some center point here, and then they're traveling, one's going this way and one's going that way. So the question is, how far have they traveled? Well, this is some distance that plane 1 travels and the distance that plane 2 travels. If I add those two distances together, I'll get the distance apart. So the distance apart is equal to the distance that plane 1 travels plus the distance that plane 2 travels. And this is only true because they're traveling in exactly the opposite directions. So the distance apart I know to be 4,000. And for the distance that plane 1 travels, well, I know it's traveling 450 miles per hour. So that's the rate. And so the distance will be that rate, 450, plus, times the time, t. And then plus the distance that plane 2 travels will be its rate, which is 550 times t. And so I should just be able to solve that for t and see what we get. So if I add those together, 450 plus 550 gives me 1,000. So 4,000 equals 1,000 t. So t is equal to 4. And the units of t is hours. Part number 8. A water tank is filled by 2 inlet pipes. Pipe A can fill the tank in 4.5 hours. Both pipes working together can fill the tank in 2 hours. How long does it take the tank to be filled using only pipe B? Answer with a complete sentence. Show all work. Okay, So, okay, so we know that pipe A can fill the tank in 4.5 hours. So what is the rate at which pipe A is filling? So pipe A's rate is equal to 1 tank for each 4.5 hours. Okay. And so I know the amount in the tank, if I do the rate times the time, then that's how much pipe A has filled. So pipe B's rate is what we're looking for. That's our unknown. And then I know that their combined rate is 1 tank per 2 hours. Okay. So I know that, so then I need to fill this all in. So I know that the rate of the combined rate should be equal to the amount that pipe A can fill plus pipe B's rate, which is 1 over, I don't know how long it takes for pipe B to fill it. So I'll just call pipe B's rate 1 over T for 1 tank in T amount of time. 1 tank in T hours. So that'll tell us, if I solve for T, that will give me how many hours it takes pipe B to fill the tank. So let's solve that for T. So I'm going to multiply everything through by all of those denominators. If I multiply everything by 2 times 4.5 times T, I'll do that for everything. What will I get? Well, I'll get 2 times 4.5 times T divided by 2 equals 2 times 4.5 times T divided by 2 plus 2 times 4.5 times T divided by T. Oh, whoops. This one is divided by 4.5. So I just multiplied that into each of these, and then I can see that 2 divided by 2, that makes 1, so that part cancels. 4.5 divided by 4.5, that makes 1, so that part cancels. And then T divided by T, that divides to make 1. So what I'm left with is 4.5T equals 2T plus 2 times 4.5, which is 9. And then I can subtract that over. I get 2.5T equals 9. And then 9 divided by 2.5 is 3.6. And so that's the number of hours that it would take for pipe B to fill the tank by itself. Number 9, a cookie recipe has a ratio of 3 eggs to 4 dozen cookies. How many cookies would be produced if a dozen eggs were used? Answer in a complete sentence. If a dozen eggs were used. Okay, so 3 eggs to 4 dozen cookies should be equal to 12 eggs per X dozen cookies. So if I just solve that, I can solve that by multiplying both sides by the denominator. So I'm going to multiply everything by 4x. And so if I do that, then that gives me that 4 divided by that 4 makes 1, and that x divided by that x makes 1. So what I'm left with is 3x equals 12 times 4, which is 48. If I divide that by 3, I get x equals 16 dozen cookies. Number 10. Find the dimensions of a rectangular pasture if the length is 400 meters or 400 feet more than the width, and the perimeter of the pasture is 1,040 feet. Answer with a complete sentence. So I know that the length is going to be more than the width. So the length is equal to the width plus 200. And then the perimeter, that's the distance all the way around. So I'm going to have 1,040 is equal to, well, if I go all the way around, I'm going to have the width 2 times. So 2W plus, I'll have the length 2 times. So 2 times W plus 200. And if I multiply that all out, I'll have 1,040 equals 4W plus 2 times 200 is 400. I can subtract the 400 over. I'll get 4W equals 640. So it gives me W equals 160 feet. That is different from what the answer says. So what happened? Okay, I was just checking the answer on the review sheet answers, and I think there's a typo there, so I'll talk to Professor Tree to fix that. So, so the width should be 160 feet, and the length should be 160 plus 200, so 360 feet. And if we check that, if we do 160 plus 160 plus 360 plus 360, we get 1,040, which is the perimeter that we needed. So we know that one can be correct. Okay, the next one is number 11. Express the following powers of I in simplest form. So one thing to remember about I is that I squared is equal to -1, and we know that I to the 4th is equal to 1. So if we have I to the 27th, I can break that down. And I know 27 is 24 plus 3. So I to the 24th times I cubed. And we know I to the 24th is I to the 6th to the 4th. Or actually, let me write it the other way. I to the 4th to the 6th. Times I cubed, which is going to be I to the 4th is 1. 1 to the 6th is 1. And so this bit all here is just 1. And then I cubed is I squared times I. So it's going to be -I. I to the -18. That is equal to 1 over I to the 18th. And what is I to the 18th? Well, that's going to be 1 over I to the 16th times I squared. And I to the 16th is going to be equal to 1, and I squared is -1. So this should be -1. I to the 64th is I to the 4th to the 16th, because 64 is 16 times 4, so that's 1 to the 16th, which is 1. I to the 33rd should be, I can think of that as I to the 32nd times I. So I to the 32nd, since 32 is divisible by 4, that's I to the 4th to the 8th times I. So 1 to the 8th times I, which is just going to be I. Number 12, write the following expressions in terms of I and simplify. So for the first one, -16 is 4, so square root of -16 times square root of 12. This is equal to 4I times the square root of 12. And 12 I can break down into the square root of 4 times 3. And when I take the square root of the 4, I get 2. And I can multiply the 2 by the 4 to get 8i. And then the square root of 3, I just have to leave like that. Okay, square root of 24 times square root, sorry, negative 24 times square root of negative 56. Okay, so I'm going to get an I. And then 24 is 6 times 4. And then for the negative 56, I'll get an I. And square root of 56 is, 56 is 4 times 14. So I should be able to pull out a 2 from each of those. So I'll have a 2 from there. And I'll have an I, and I'll have a 2 from there. Okay, and then let's move some things around here. So I can put that 2 and that 2, I can multiply together. So I'll have an I times I is I squared, which is negative. So I'll have 4 square root of 6 square root of 14. So I can keep going. I'll get negative 4. I can take square root of 2 times square root of 2 and get another 2. So I'll have 2 times 3 square root of 2 times 7. So I can take those two 2's out. And when I square root them, I'll get a 2. So negative 8 square root of 3 times square root of 7. Okay, let's look at the last one. I have square root of negative 20 over square root of 45. So let's see how this breaks down. I'll have an I on top, and I'll have square root of 20 is 4 times 5, and 45 is 9 times 5. So that'll be I times 2 square root of 5, and on bottom I have 3 square root of 5. So this is 2I over 3. Okay, number 13, I want to identify the real part and imaginary part. So let me erase that. So for A, it's negative 5 plus 3I. So the real part is negative 5, and the imaginary part is 3. So negative 5 and then 3. 13 part B is 4 minus 2I. So the real part is the 4, and the complex part is the negative 2. Or the imaginary negative 2. On C, we're looking at negative 6 minus 4I. So the real part is negative 6, and the imaginary part is negative 4.